in this problem, to find y, I'm going to have to go through a few steps to get there. And we're going to look at a couple of ways we could approach this. First of all, I'm going to think, well, I don't have two opposite pairs where one of the things is the unknown because I don't know the angle opposite y. So I can't directly apply the sine rule. I also don't know the two lengths either side of the angle that I know, so I can't directly apply the cosine rule. So I'm going to have to do something a little bit different here. I'm going to show you two different ways we could approach this question. The first way is using the sine rule. So the sine rule, we know this pair, and we can't do anything with the y because we don't know the angle opposite, but we do know the 10, which means we can find this angle here. I'm going to call this angle theta. So sine of theta over 10 is equal to sine of 61 over 9. That means that sine of theta is equal to 10 sine 61 over 9, and theta is equal to sine inverse of 10 sine 61 over 9, which is equal to 76.361. Now that I know that sine theta is equal to 76.36, I can work out this angle here by doing 180 minus the 76.36 minus the 61, and I get that this angle here is 42.6. Now that I know the 42.6, I can actually do a cosine rule using these three to find y. So y squared is equal to 9 squared plus 10 squared minus 2 times 9 times 10 times cos of the angle between them, which is at 42.6. Now I'm going to use the answer button in my calculator to get this as precise as possible. And I'm also going to square root. So y is equal to the square root of that whole thing. 9 squared plus 10 squared minus 2 times 9 times 10 times cos 42.6, or the answer button, which is equal to 6.97. Now let's consider the second approach to this problem. I'm going to delete all of this, and we're going to look at it from a very different perspective. This time I'm going to use the cosine rule directly using these three. And what that means, substituting in, is that 9 squared is equal to y squared plus 10 squared minus 2 times y times 10 times by cos of 61 degrees. Now the easiest way to solve this is to plug it straight into our calculator and solve the equation. I would graph it, y1, y2. And when I get those two graphs, I find the intersection. Now the graph of that looks something like this. It comes down as a parabola and then a horizontal line going across at 9 squared, or 81. That means we have 2 points of intersection, which is expected because this is a quadratic. This first one we find is equal to 2.73, and the second one we find is equal to 6.97. So this is suggesting that there are two solutions. The 6.97 matches up, so y equals 6.97 matches up to what we found before. But this is suggesting there's also a solution where y is equal to 2.73. And that is absolutely true. It is a valid solution, which we didn't easily find through this approach. What we will see shortly is how we might get to that using this approach as well. In general, I would say the cosine rule is more likely to give you the answers or the multiple answers than this approach, and you're more likely to miss one of the answers using that first approach. But as I said, we will see where that second answer comes from in a few examples' time.